Hi, I am really grateful to be speaking with you today on behalf of our project team about a project that is focused on building coastal resilience down on the coast here in Georgia. And I'd like to acknowledge my co-leaders on this project, Russell Clark from Georgia Tech Computer Science, Nick Deffley from the Office of Sustainability for City of Savannah, and Randall Matthews, the Associate Director of the Chatham Emergency Management Agency down the coast. So without further ado, let's talk about what these coastal communities are facing and how some additional sensor networks, associated modeling tools, and education awareness building can together create a systems level approach to some of the short and long-term challenges that these communities face. And so looking at the data from Fort Pulaski down the coast, the situation cannot be any more clear in terms of what these communities are facing. This is data showing categories of minor, moderate, and major flooding. And it's important to note that over 60% of the major flooding that has occurred since 2015 down on the coast. And it's not just during large hurricanes, it's also happening during so-called blue sky flooding events or sunny day flooding events, whether it's a king tide or sustained winds from a particular direction over a particular amount of time. You can find patches of flooding across the county that happens in a very complex pattern that's very difficult to predict and difficult to observe with the only tide gauge before this project started at Fort Pulaski. Going much longer into the future, we can look to the National Climate Assessment for the official consensus estimates of future sea level rise on the coast. So this is from the 2018 assessment, looking at +1 to +4 feet of sea level rise by 2100 as a likely scenario. And they are very careful to point out that up to 10 feet of sea level rise is actually possible from a global average. And this is where our project comes in, thinking about how can we increase the eyes on the ground through internet-equipped sea level sensors that you can see in the upper right-hand there, and looking to integrate these data streams into emergency planning and management tools. Also looking to leverage these data streams to build very high resolution coastal ocean models that are capable of forecasting coastal flooding in all its complexities through space and time, with 3-day forecasts to give folks enough, of course, planning horizon for emergency planners and managers, but also thinking about how we could use those same tools fully integrated with infrastructure to create platforms for decision support for decision makers, policymakers, and organizers who are interested in thinking about what are the best ways to mitigate flooding risks over the coming decades of continued sea level rise. Of course, we're also thinking about education and awareness building because this is a multi-generational challenge. And it certainly is important that we think about K through 12, but also the community members who have got to play an important role in the solution set. And so with that in mind, I'm very happy to talk a little bit more in depth about the ultrasonic sensor that we have developed here at Georgia Tech using off-the-shelf parts. This is extremely inexpensive, accessible to many coastal communities, $250 in parts. It can be powered either by D batteries, or we've also developed a small solar panel that can be integrated for more remote and sustained operations. We're using a LoRaWAN communication protocol that in which these sensors talk to fixed gateway devices installed across the county, and they're internet connected, and so those data streams come from the sensor to the gateway device and to our servers at Georgia Tech to build out that infrastructure. We are currently installing these sensors on bridges and docks, public and private, across Chatham County, and with a couple sensors already installed outside Chatham County, and perhaps a major expansion of the network coming soon with pending funding from NOAA. I wanted to call out a special shout out to Jenkins High School students, one of whom is pictured here. They have helped us assemble over 30 sea level sensors to date. And that program is through the engineering curriculum. And I think we can all understand the power of getting this generation involved in hands-on activities that they can see deployed in their communities, solving problems today, creating solutions for tomorrow, to help keep people and their livelihoods and infrastructure safe. So the gateway device is, we have about 14 of these installed. This is also an off-the-shelf component. It uses the LoRaWAN protocol again. These are a bit more expensive, beginning at about $1,500 to $2,000 for a marine grade weatherproof station, such as that you see pictured on the left here. And this is a sensor that can collect data from hundreds of different Internet of Things sensors, and it not just be sea level sensor data. It can be temperature data, pressure data, air quality data, traffic data, you name it. Somebody's designed a sensor to collect these data streams. They can be aggregated to these gateway devices and, of course, delivered to servers both down the coast and up here at Georgia Tech. And this is a backbone that we're creating of these sensors across Chatham County, and again, hoping to expand down across the rest of the coast of Georgia soon. And so we often get this question, how well do the Georgia Tech sensors perform when benchmarked against the Fort Pulaski tide gauge, which is, of course, the gold standard for sea level measurements along the coast? We only have one of those, and so we are very fortunate to have 2 Georgia Tech sensors installed alongside Fort Pulaski tide gauge now for well over a year, in fact. Big thanks to NOAA and the Fort Pulaski staff as well for helping that come to fruition. But here you can see the 2 Georgia Tech sensors in the colored lines against the Fort Pulaski tide gauge in the black lines. So you can see that they directly overlay our sensor data streams, are definitely capturing the tidal cycle as well as some higher frequency variability that we can see in that tide gauge data. So all in all, the Fort Pulaski tide gauge is well within 1 inch of the Georgia Tech sensors at any given time, with a maximum departure of about 6 inches. And it's really important to keep in mind that these sensors are not looking at the exact same parcel of water. They are offset by a couple meters. And so through wave activity, you can absolutely envision that there will be several inches of play between our data and the Fort Pulaski tide gauge. That doesn't really reflect an accuracy issue. It just reflects the dynamic nature of the surface ocean. One of our biggest goals and ambitions is to try to build a modeling framework that can provide forecasting abilities at the neighborhood scale for the entire Chatham County area for right now. And going forward, we hope to expand that up and down the southeastern seaboard. You can see the modeling domain in the upper left here. It is a high resolution coastal ocean model. I want to give a big thanks to a group led by Nadia Pinardi over at the University of Bologna, who has helped us develop this model for Savannah all the way from Italy, and obviously sees a big application for this kind of infrastructure over in Italy as well. But what we're able to do with this kind of modeling framework is compare what water levels have been like over past flooding events. I'm showing you Hurricane Matthew on the bottom panel here, compared to what actually happened in the observation. So the model version of reality is in black. The actual observations as they occurred are in pink. And I think you can see that the model does a really good job at understanding the magnitude of flooding at the Fort Pulaski tide gauge in this case. And the idea is to use the entire expanded set of sea level sensors to input into the model to provide the most accurate near-term forecasts of where the water might be in a matter of hours or days, but also to think about how we could use the same model to project what a hurricane like Matthew may do in 2030, 2040, and 2050 to guide infrastructure decisions and around critical infrastructure and investments that the communities will make over that time. I want to acknowledge all of the amazing partners that we are so privileged to work with along the coast of Georgia and beyond as we've lifted up this project. So at the core of the project teams, we have Georgia Tech, City of Savannah, and Chatham County, but you can see that we very rapidly get into a much larger set of stakeholders that includes NGOs, environmental justice organizations like the Harambe House, which has become a very key partner, Georgia Sea Grant, 100 Miles, National Weather Service. I cannot possibly list them all, but this doesn't even do them justice, even the amount of logos on this slide. So we're grateful for the partnerships, and it's this kind of dynamic ecosystem that helps us understand the community problems that are surfaced for our team to keep in mind as we go forward, but also think about where can we partner to get sensors on the ground? Where can we help leverage talent across these different organizations to help improve our products and our tools? I want to make sure to mention that while I've talked about sensors, I've talked about modeling, social science plays a critical role in these solution sets as well. And with this slide, I'm lifting up the work of my colleague, Dr. Yana Lukisis at Georgia Tech, who is really developing this tool called the Map Room for community engagement, for collecting input from residents and stakeholders, but also a way to reflect out what the sensor network looks like, where the flooding may occur. So it's a fabulous forum for exchange. And the really fun thing is you get to put a marker in your hand and literally draw your neighborhood onto this map that's guided by a projector onto this blank sheet of paper. It is so fun. It's a very rich way to collect the kinds of data from local experts that we need to have on our team. And I'm really grateful to have a partnership at the Harambe House to help us understand how we can better serve residents and include these local experts in guiding our work. So I just want to end by just recognizing that we have only just begun this work. Even so, we have 50 sensors on the ground. We'd like to expand that to several hundred over the next couple of years. But we have really taken a very strong push into the climate justice work. And in this is basically my plea here to start to consider how we can build capacity that's comprehensive, that's inclusive, and that really spans from the technology, science, and engineering side all the way over to the social science side, and all of that encased in a network of partnerships that can help move this work forward, help inform the work, help deploy the work, help co-develop the work. And so with that in mind, we've proposed a Coastal Equity and Resilience Hub to the National Science Foundation, and whether funded or not, we will continue to chip away towards this model. It involves Georgia Tech, UGA, Savannah State, and University of South Carolina, as well as NGO partners like the Harambe House, the Pinpoint Betterment Association, the Coastal Georgia Indicators Coalition. The list goes on, but I'm grateful for the partnership that we do have in helping us to translate this into reality, step by step as we can. And so one of the lessons we can take from this is that it's really important to have these cross-sector conversations from day one. It serves absolutely nobody to get in a room at Georgia Tech and have 10 experts think about what we should do to serve coastal communities. That's not going to really lift up the most powerful and impactful and durable solutions. We really need to think about how we can create fora and structures and funding to enable people to stay in conversation, stay working together, not just today and tomorrow, but for decades to come, because this is a multi-decade challenge. The other thing that we've learned in our team is that we aggregate all of these research experts like a snowball rolling downhill. It is absolutely humbling to see how badly researchers and experts want to deploy their disciplinary skills and tools into lasting change that's really driven by community priorities, especially around a challenge like climate change that we know is going to be here for so long to come. So thankful to have over 20 faculty at Georgia Tech involved, many different faculty from these other institutions I previously named, and growing every day. So stay tuned. The other thing that has surprised us is that what we went into thinking was an outreach activity around K-12 education has turned out to be really one of our highest value propositions to every stakeholder we talk to down on the coast. And so whether it's the mayor, a county commissioner, a business person, of course, the superintendent herself, we really have received such accolades and gratitude from everybody we've talked to about the deep investments we've made in building out middle school curriculum, high school curriculum, and including educational activities in every single proposal we've written with an eye towards really advancing curriculum around coastal resilience. And again, our aim is to build the workforce of tomorrow for coastal communities so that the capacity and the talent can be tapped from in-house in these communities where people live, and that there can be a steady pipeline of people that are ready to work together across this complex space to advance lasting solutions. So we have been humbled by the appetite from teachers, schools, and students, and we continue to try to grow that with every move we make. It is no longer an afterthought or an add-on. It is a core theory for change and a core ingredient to our work. Last but not least, we learned the hard way that we did not have justice, equity, and inclusion centered as strongly in our work from the beginning as we should have. And we realized this when we started to look around our stakeholders, people that were landing in our inbox, people who were coming to our workshops, and there were whole segments of the coastal community that were not represented, that we were not talking to at that early stage. And so it really took some really amazing outreach by Nick Deffley, and some willingness to work with us through organizations like the Harambe House that have enabled us to center justice, equity, diversity, inclusion in the core of our work as we think about what does it mean to serve coastal communities if you aren't serving the most underserved members of those communities. And indeed, that is really what the Coastal Equity and Resilience Hub is all about. And I hope I've piqued your interest in some discussion and questions, and I'll leave it there in endless gratitude for all of our partners and real excitement and hope for what lies ahead for coastal Georgia.